Hello, everybody, and welcome to today's webinar presentation, Greater Visibility into Network Monitoring with Open Source, brought to you by InfluxData. I'd like to introduce you to our presenter, Daniella Pontes. Daniella is part of the product marketing team at InfluxData, San Francisco. She started her career in telecommunications, wireless technology, and global internet service provisioning. As security became a major concern for enterprises, she worked on enterprise policy management, SaaS, and data encryption solutions. Prior to joining InfluxData, she spent some years living in Japan, Germany, and Brazil, working for an online agency developing and managing the Brazilian market. Having worked in various segments from embedded smart antenna technology to internet security and e-commerce, doing product management, partnerships, marketing, and business development, she has a broad experience working cross-functionally with customers and partners.
Okay, now I'm sharing my screen. Another hello, everybody. I'm Daniella Pontes. I work for InfluxData as part of the product marketing team. And I'm here today to talk to you about getting greater visibility into network monitoring with open source. Let's get started. Okay, let's see. But first, let's do a proper introduction. Yeah. What is InfluxData? Well, InfluxData is, just a second. InfluxData is the open source time series database. And you may have noticed a tiny little bit pride in that statement. And it's for a good reason, folks. We believe that what we do here brings great value to organizations and professionals trying to better the way that they do things, that they execute their jobs. And we do that by providing real-time visibility into stacks, sensors, and systems. A little bit more context on InfluxData. We were founded in 2013. We are headquartered in San Francisco with about 115 full-time employees and half of them being in technical functions. Our mission is to be the modern engine for metrics and events. And by modern, we mean purpose-built time series data platform. We will get into details of that later on. Our focus is on this main source for timestamp data, and those are the monitoring solutions on sensors, infrastructures, and business process. And when we talk about infrastructure, we talk about everything, from the infrastructure per se, but also the networking and the application aspect of it. How we make the difference? We make a point about being simple and easy to start and expand. So we provide the fastest time to awesome. We enable you to take real action and in real time. So being effective is crucial. Our presence today is about 200,000 active deployments and over 500 customers. Among them, you can see IBM, Cisco, PayPal, Tesla System, Comcast. We are in practically every segment out there because it doesn't matter what kind of solution or application you provide or you run. What matters is that you are collecting timestamp data and you want to monitor that sampling. Our business model, we are an open source distribution with a closed source economics. What does it mean? It means that on top of our open source, we create additional deployment options with value-added services. So for those that don't want to manage the platform in-house or don't want to have the headcounts or the headache or whatever, you can add or migrate to the enterprise version of it that comes with high availability, clustering, and additional security features. And also, if you want to have everything on the cloud, we have the cloud option for you as well. And those are paid versions. But if you want to stay open source, you are free to do so for as long as you want. So let me provide some numbers to back up those bold statements that I have been making. So this graph shows you, how much have we grown since the start. It's a clear exponential growth rate. And why is that? And the answer is here in these two other graphs. So DB Engine provide monthly, research reports on database segment. And you can see here on the left side that time series is the fastest growing database type out there. And you can see how it compares to relational search and graph database. On the right side, you can see how InfluxDB stands out inside of that specific time series database. And that does not just compare it related to open source, but also proprietary solutions out there. So clearly, InfluxDB is the preferred choice. So, and why is that? Why so much interest in time series and InfluxDB? Well, to answer that question, we need to understand market drivers. We are living through the age of instrumentation. We are a data-driven society. And time series management, time series database is in the center point of two converging trends. On one side, you have the sensorification of the physical world. Every surface out there, every infrastructure out there that has any interest of monitoring and understanding how it is behaving is being monitored. And that means, with smart cities, making sure that public infrastructure is as it should be and providing the necessary benefit to the society. Or utility companies that wants to monitor their deployment of wind generation energy or solar panels deployed out there in the field. Or could be also yourself, trying to manage your house, making sure that your webcam is working when it should, that your heater or your air conditioner is just working when it should, saving you, on the electricity bills. And also for you to monitor yourself, with the IoTs, the consumable and wearable device and telling you that you didn't walk enough today. So this is sensorification of the physical world. And on the other side, we have the instrumentation of the virtual world. What is going on is the society lives on software, on applications. Application guides us. And those applications, those softwares, they are creating layers and layers of abstraction, hoping that everything will come together, work fine as one, in unison. And in order to guarantee that will happen, you need to manage and monitor every single interface you have out there, boundaries between services and how they are connecting to each other. And these two trends is generating a tremendous amount of timestamp data that needs to be collected, processed, and storage. So let's now talk about monitoring, which is what we are here for today. What you see in this diagram is basically a reflection of what you have there in IT, at ops. You divide your teams based on what they need to do in terms of what they need to be responsible for. You have on the right side, what we call the application team. They are there building software and application solutions that enables the business or the organization to function, that delivers the features and the value that customers are willing to pay for. And they create that software or their application, and they define, what kind of resources they need for that application to run as it's expected to. And they deliver these specs to the infrastructure team that will make sure that they have the box, the VMs, with the necessary capacity to handle the workload. And that meant, the CPU, the memory, the disk space, and everything would be just fine. On the left side, we have the network team just minding their business in terms of, let's make sure that the traffic goes from where it starts to where it should be, from source to destination, just fine. So making sure that your routers, your switch, your load balancers, and by the way, your WAN as well, if you have remote offices, are just working as expected. As companies and organizations started to trend off premises, in hosted environments or hosted services or in the cloud, there is another team that needs to do some monitoring. It's the end-to-end team. They need to make sure that the SLAs are being respected. And that's how world used to be. So let me tell how it is now. The application team got pressured. And now competition is one click away, and competition is worldwide, and anybody can start competing with you. So they had to stay, at market feature parity and be ahead of the game with additional value-added features, capabilities, and performance. So in the way that they found to serve that demand and release the pressure was to say, okay, I cannot do what you're asking with these monolithic applications that we design and architect. Has a huge development cycle, release cycle, testing cycle, production cycle. So they broke the application into smaller pieces, into services, microservices. And those services, they work independently, they are processes that run independently, and they just need to make sure that they define the interface of those services to the next service that will take their workload to the next step in the application flow. And by doing that, they could fulfill the expectation of continuous integration and continuous delivery. Everybody was happy. And now you can get your features, your fixes, your upgrades, timely, and you can kind of beat the competition, by the way. And what they did was they said, okay, infrastructure team, now you don't have to give me a box of VMware to run my application. You just need to run these little pieces of software that are services that, by the way, needs to be up and running and performant and talking to each other. And the infrastructure team, okay, now what I need to do here? I cannot just put one VMware for each one of this tiny little thing there. It would be a lot of resource, wasted. So they created what is the container, called the container, much lighter, much more efficient in terms of resources allocation and consumption. And by the way, they are ephemeral. You can create and delete them, and they appear, disappear as needed. It's a very efficient way of managing your infrastructure. And they said, okay, that's good, but not good enough. We need to encapsulate that because there are certain kinds of containers that they need to talk to each other in a closely and in a bounded way. And we need to manage that state of deployment to make sure that stays as it planned at deployment phase. So they created, the pods, the Kubernetes, and the whole logical orchestration layer on top of it. And everything now is fine. We can deploy the services. They can be monitored in terms of deployment. They stay up and running as I need. They get replicated as desired. And if something goes wrong, we just delete one and bring up another one. Everything is okay. And by the way, application, we are taking care of your fragmented environment. But nothing comes without a cost. Yeah. They made it to work. They are timely in terms of delivering features and functionality to the market. They are efficient in terms of user infrastructure, but that came with the cost of complexity. It's exponential. Before, what you used to be one piece that you would watch for now is a bag of cats. You have little parts of software that is running independently, by the way, also in a container which is separate from another container that could be in another node, that could be in another remote center. So every now is separated. It's the degree of complexity added to both the application environment and the infrastructure environment is just tremendous. But the hot potato actually ended up on the other side of this graph, on the network monitoring team. And I will tell you why. Because all that was done in the application and in the environment, in the infrastructure environment here, breaking apart everything, making everything work independently, was done with the premise that the network that connects everything, that keeps everything together, just works. So for the network monitoring team, glitches, performance degradation is a no-no, cannot be accepted anymore. Because one service that is malfunctioning because the network that's connecting to the next service or the next stop in the request path is being not performant can create a cascading event and bringing down the whole application environment. So the network monitoring team now needs to deal with the requirements that, make the network disappear practically, make no more a factor. It's just performant. It's just there. It's just work for granted. And that means monitoring, stay on top of things, staying ahead of the curve. And in order to do that, they need to be sure about what they are collecting, at what granularity, so they can be effective in terms of anticipating potential breaking points. So the good news for the network monitoring team, is that although they deal with a very complex environment, both at the application layer as well as the infrastructure layer, and they are there in the middle trying to connect everything, filling all the gaps, all the making sure that the separations are linked so everything works. Network monitoring, I would say, has three foundations that you need to watch for. And with these three pillars, you can go from an unmonitored network to a monitored network, where you can make sure that you are doing the job that the application and the infrastructure team is expecting. So what are those three main pillars of network monitoring that you need to be observant of? First, you need to make sure that the network is available. That means that you can go from A to B, and you can route the traffic is supposed to route. So basically, you want to make sure that everything in the network path is up. And if it is down, you need to be notified immediately. So you need to have information about the health checks of, the routers, the switch, the load balancers, all the main players in that kind of environment, but also the additional ones that are needed in order for you to do your networking, like, DNS server, net servers, whatever you have there that makes sure that your traffic flows as expected. I have here some samples or some examples of type of availability checks that you could be doing. But of course, as you understand your network layout and deployment, you will find the metrics that are appropriate to you. But the load balancer is always a hot spot there. is the box that is, being hit by the entire traffic that needs to reach your servers or your hosts there. And it's in the load balancer that you get a lot of information about, how the network interface or network is dealing with that traffic, and how the target endpoints to where the traffic gets sent to are responding to that. So keeping an eye on the load balance is something that definitely every network monitoring solution needs to do. But other things that you could be paying attention as well that could deny the network access needed for your services and application is, for example, the certificates. The certificate expired. It's a simple thing to check and to stay on top of it. But if you're not monitoring it, it expired, traffic is denied. Another pillar of your network monitoring is about responsiveness. Okay, I check, the network is available, I can send traffic from A to B, reach the points where they're supposed to reach, but what kind of responsiveness I'm providing in terms of latency, packet loss, error rate, jitter, and your network interface, by the way, what kind of load you are seeing there. Maybe some of the load that you experience is because you're jamming your network interface. So making the network always available in terms of uptime and routing, the traffic is not enough, because depending on the applications that are running on that network, depending on the traffic that you have in that network, certain kinds of latency is not acceptable. If you're dealing with multimedia streaming, for example, unified communication, voice over IP, video conferencing, they are very sensitive to latency and to jitter. So you need to make sure that you understand the responsiveness of your network, so the applications running on it will not notice the impact of a deviation from the thresholds that it's defined for optimal operation. And the third pillar of network monitoring is understanding how your bandwidth is being consumed. So who, when, and how much is being consumed. So this is about flow, is to identify the flows that you have in your network. And for that, you need to tap into information about IP, protocol, and port, and group them into flows to understand who is using what. And by doing so, you have a better understand of what could be a malicious traffic, or non-legit traffic, or malformed traffic that could be an indication of something that is going on another side of your monitoring. By checking also, understanding your flow and your bandwidth consumption, you can also have a hint or early detection of what could be like, for example, denial of service attacks, because suddenly you see a different level of usage in your network. And you could also identify a misusage of your network, certain applications that are being consumed, that are consuming your network and should not be doing so. And as you see on the right side of this diagram, this high-level diagram, you have what it is, the InfluxData platform. So once you define of what you need to monitor, what you want to be alerted on, you need to bring all that data to a place where it can do the proper management. So on the right side, you have the InfluxData platform that provides you with a collection agent and a community of data sources that are in collaboration with Influx DB. We have Influx DB as your time series database that can be the repository for all types of data that you are collecting in your network. We provide also a visualization tool, chronograph, and a real-time analytics engine, capacitor for alerting. And all of this is open source. So here is a high-level diagram of the architecture of the platform. And so let's talk a little bit about how. Yeah, we talked about what you should be doing, but let's see how you could go by using these open source tools and open source solution that is out there for you to do your work, your job in terms of network monitoring. So let's start with the collection part of it. Telegraph is our collection agent. It's very lightweight and it is plugin driven. As of today, there are more than 200 plugins out there. For most for the applications and the services that you commonly find in your network, being it an Apache server, Kafka message bus, your SQL server, your routers, everything that you commonly find in your network practically has already a plugin written for it in Telegraph. And 200, this number is about the plugins that are actually officially part of the Telegraph library. But there are a lot of plugins that were written as private projects from people that are interested in monitoring specific things on their personal time. And I actually had that experience recently in Google Next conference. A lot of people that came to talk to us about time series had their own projects going on. Said, oh yeah, I'm familiar with you guys because I did this little project as an experiment thing, and I'm bringing that experience to what I'm about to implement in my company now. So there is a lot that was already done there, but it's not part of this official library that is in GitHub. But I wanted to highlight two main Telegraph plugins that is out there for you and can take you a long way in terms of network monitoring. One is the SNMP plugin. With SNMP, you can collect a lot of information about your router, your switch, your load balancers. You can go to your MIBs and fetch information about your network interface or your system stats. For example, whatever you want to monitor and you make available in your MIBs, you can use the Telegraph SNMP configure with that OID to fetch that information for you and bring to Influx DB for central monitoring. Another plugin that is there ready for you to use is Ping plugin, Telegraph Ping plugin. Ping is a wonderful tool. It's out there in any possible, in any device or platform that you have in your system. I bet with you that you have Ping already as part of it, as a tool already coming with it. So, and with Ping, you can do a lot too. Ping can give you a great visibility in terms of performance. Not only availability, of course, that is the most common use case. You go there and check if you can reach that destination, but you can also use Ping to make sure that the network is responsive. You can check latency, error rates, packet loss, jitter. And again, this is already there for you to start using. And all of this data is brought to InfluxDB and can be already presented in pre-canned dashboards that is made available for you in Chronograph. I would like also to point another resource for you. It's not a plugin, but it is an integration solution that we have with our partner Ontop. So Ontop is a traffic analyzer. is also open source, by the way, and they have InfluxDB integrated in their solution as their choice for time series. So everything that they collect in terms of traffic analysis is already sent to InfluxDB in native form. So you could just, if you want, ship all that data to a central InfluxDB that is also receiving data from other data source. And with Ontop integration, you can have, you can collect information about with NetFlow and SFlow. So Ontop can receive those NetFlow and SFlow messages, and they can use that data to identify the flows coming from a specific IP address or port or protocol. And with that information, you can tell how your bandwidth is being used, if the traffic is legit or not, if it is supposed to have that kind of behavior or not. So besides these three collecting options that we make available for you from start, you could consider also other solutions, other collecting tools and plugins that are available to enrich or give you other options in terms of how to collect the data that matters to you. One of them is Syslog. We have a plugin for Syslog, so all your Syslog data you can send to Telegraph, can receive and can send to InfluxDB. So why would you do that? Although in order to be effective, in order to be real time, you do need to monitor in terms of metrics, in terms of granular intervals. You need to catch the deviation as soon as possible. So metrics first. But once you get that indication that something may not be doing well, may have some kind of trouble, you should be able to collect more data, contextual data, to help you diagnose and go quicker to the root cause. Yeah, so you could tap into Syslog data to get contextual information about, who, exactly what else is being reported from that kind of machine or from that kind of IP. So you can correlate that data to help you diagnose what's going on. And that is also available for you as a plugin, as a Telegraph plugin, and also as a predefined, pre-canned dashboard in Chronograph. Another one that I would like to talk about is JTI OpenConfig. So this plugin is for the devices or appliance or host that you want to monitor that has support for Juniper, Juno telemetry interface. So a lot of the more you monitor, the more information you collect from your endpoint, your appliance, the more you use the same resources that you want to manage, so monitor. So it's kind of a dilemma, how much monitoring is too much monitoring. So but you cannot just not monitor, you should not just give up about knowing what's going on. What you need to do is balance the way that you do your monitoring. So making use of telemetry that is available to you, like Juno telemetry, that is a better and faster, more efficient way to collect data from Juno-enabled appliances. Yeah, sure. So you reduce the amount of SNMP pooling that you incur on your network and your device, which consume both bandwidth and CPU cycles. Another one that is already available for you from the start is Cisco Pipeline. All the Cisco routers and switches out there that support Cisco Pipeline, you can monitor with the integration with that's available with the InfluxDB. So Cisco Pipeline can output all this telemetry data in native InfluxDB data format. So everything can send transparently to streamlined in a streamlined way to InfluxDB. Two other collection mechanisms collection modules that I would like to point out. First is Nagios. there is a integration module already for Nagios. Nagios was one of the first monitoring tools out there and did a good job for what it was built for. But now it's facing serious challenges in terms of the scalability. You know, the amount of monitoring data, you know, grew exponentially, as we've seen at the beginning of this presentation. And so Nagios is no longer, you know, the tool that will help you with all the monitoring that you need to do in your network. But, you know, you should not touch on something that is giving you value. If you have Nagios in-house and you're already monitoring certain aspects of your network and it's doing a good job for you, you should not just waste all this work, because Nagios has a very, very steep learning curve. And if you have all that work already done for you, you know, just keep as it is. But bring it to a central point where you can see that information together with everything else that you're monitoring. So you don't have a narrow view of what's going on, and you can augment that information with other correlating, I would say, data points that can give you a more insightful feeling of what's going on in your network. And the final one that I want to talk about is Metamiko. Metamiko was acquired by Arista, and Metamiko focus on the finance market. Metamiko is an optical switch, very, very high speed. And why? And guess what? It's expected to do so. If they focus on financial market, they are in a very sensitive market to latency. You know, they are in a constant race to, you know first about stock price fluctuation, you know, sell first, well, buy first. So they need to have that kind of speed and granularity. We are talking about nanosecond kinds of time interval. So they needed a time series database that could handle that volume and ingest rate. And guess what? They picked Influx DB. If you have Metamiko, you have Influx DB as your time series database. And it's already there for you. So on the right side, I just wanted to, so this is about how to go by collecting the data that you need to monitor your network. On the right side, I just want to complete the view for you, the architectural view. You know, everything comes to InfluxDB. It can handle the volume, it can handle the write rate, it can handle the query rate for real-time analytics. And for that, we have Capacitor. Capacitor is the real-time streaming data processing engine where you can define your thresholds to be alerted on. So you can take real-time actions as well. And we have Chronograph, which is the visualization tool, which already brings to you from the start dashboard that can start guide you in terms of what is going on in your network. And then you can see here as some example, you know, Kubernetes. We have dashboards for Kubernetes. We have dashboards for network monitoring like SNMP. We have dashboards for Syslog information, a specific dashboard for different applications that are commonly used in organization networks. So, and another point, the final point that I want to make here is once you have all this information in one central point and ready for processing, for correlation, and for identification of issues early enough or trends that could lead a break point, you are in perfect position to feed also other kinds of frameworks that can give you a little bit more in terms of modeling, prediction models, and behavior analysis. So you can feed all this information to service discovery frameworks, anomaly detection framework, machine learning framework, and many others. Artificial intelligence framework, all of those kind of frameworks that work on data, understanding data and how metrics or measurement behave over time will fit from what we are collecting with InfluxDB. So if I was going to summarize what to look for when you are thinking about adopting a network monitoring solution, I will make sure that certain aspects I would not compromise. And what would be those aspects? First, by necessity, when you're talking about monitoring, you need to be borderless. You cannot be put on a box. You don't know what is the next metric that you need to monitor. You don't know how many more different kinds of events you need to watch for. And you never know what your application team will, start needing in terms of, monitoring their inter-services, network. So you need to be open source. You need to be free to start and to expand. And you should not be compromising with that. The heavy lifting work that you need to do anyway. It's for any kind of solutions that you decide to adopt, because you need to understand what you want to monitor, and that's where your own brain cycle should be. What I need to monitor to do my job. That's what you should concentrating, and from that you just need to add one more metric, one more event that you want to listen to. You should not be worried about, okay, what is the best combination of license and the number of metrics that I need to use, and because you end up in the same path always, you will compromise monitoring over your license budget. Another thing is, by design, you need to be resource efficient, and that's why we say that you need to look for solutions that are purpose built. We are talking about hundreds of millions of time series monitored, managed, stored, hundreds of millions of writes per second. Thousands of queries per second, hundreds of queries per second. So in real time. So you need to be efficient, because even though you get a solution that can ingest all of that, you need to make sure that you just keep what you need, what you can extract value from. So being efficient is also about handling data and life cycle, not only gathering data, not only having the data. You need to be able to automatically evict data as when you no longer need it. For example, certain kind of metrics is very, very important for the first week to be very granular, like you collect a sample every second or even sub-second kind of time interval. But after that week, you could just summarize that data, or get an aggregated average just to guide you through modeling and profiling that specific metric. But you don't need to keep that raw data. Why would you pay for storage for data that is not serving you? It will just create a sea of data for you to draw on in. So having that resource efficiency as part of your solution is fundamental, because we are talking about huge volumes. And by go, you want to be preemptive. What is preemptive? What is the point of monitor anything if you need to wait for the phone call to tell you that your network is not doing the job that it's supposed to? So you need to anticipate that call. You need to be the first one to know. You need to be the one that acts in an effective manner. So it's not only about being able to find, the issue. If you look deep, if you do a search, if you have that data there and you eventually do a query and find that data, you need to be informed when something starts going wrong, crossing a certain threshold right away. So you need to be real time. So basically, you need the right tool for the right job. We live in a world of specialists. Yeah, we have database for everything. Database for documents, for graphs, for relational, contextual data. We have, the lakes for completely unstructured data, and we need specialists for time series. And these specialists need to be open source to give you the freedom to start and expand. The specialist needs to be performant, needs to be optimized for processing, compressing the data, querying the data in high volume in real time so you can be effective in what you do. So it needs to be able also to ingest and deal with all sorts of data that is made available for you in order to do your job. So it needs to be able to correlate data to guide you through the resolution as well. So it's not just alerting you about something is wrong, but guiding you through making things better. So what else? So what I've been talking about is related to that 3 main pillars of network monitoring that you can start, right now with open source, and you can stay open source for as long as you want, and just migrate to, any kind of other paid services when you feel you have the need for. But what else you should have in the back of your mind? You don't have to do everything at once. You can start easy and fast. But what else you should keep an eye on, keep your mind open to? First, the speed of things today is just too much. There is no room for guessing. So more and more you should look to be to target your alerts, to target your actions. So what we are working on is to get more and more granular monitoring on traffic by user, by process, to be able to tell you, look, in this big crowd of things going on here, that's the guy that's causing trouble to you. And then you can go straight to that point and address the issue. And we are doing that by working with our partner Ontop on eBPF data, collecting data right from the kernel, and this is especially important in environments like Kubernetes and pods, where you have that encapsulation, where you have containers and they talk to each other, and that traffic never hits the network interface. So you need to monitor that from the inside. Another thing that you always keep in mind is you need to take advantage of centralization. Seeing the whole picture is fundamental. So bring everything into a central point. Enough with silos. Silos that doesn't give you the answer. Silos just tells you that something is wrong in that specific area, but most of the time it's used for people to say it's not me and not really address the issue. So you should be you should look for cross-measurement analytics. You should take advantage of all this data that you are collecting and make sure that they contribute to issue resolution. And another one is that whole concept of observability. So observability is the other side. Monitoring is one side. It's checking how things are working from the outside. And observability is understanding the intricacies of what is going on from inside, the service boundaries, and, how they are talking to each other, the join, the forks, making sure that everything is flowing from the start of a request to the end of that request successfully. So that is what we're talking about is causally related events. They are also time-stamped, and they are also meant to be managed by time series. Okay, enough of talking what can be done. Let's talk about things that are done now, that is implemented now and is doing the job that needs to be done. So NFL.com, their website, use Influx data as the monitoring platform for network monitoring. And they use SNP to get the metrics that they need from the switch, the routers, the firewalls, load balancers, and they collect data that are meaningful to them to make sure that they keep their website performant to their users. So throughput per second, seconds, system level stats, and even, the response time. The response time for HTTP requests. So another one is Hulu. Hulu is nothing less but this service that provides streaming, and so network is fundamental here. They need to make sure that they took that responsibility, the hot potato responsibility, on their hands when we talk to them in terms of what we are talking about here in terms of SLAs and target uptime. It is what we're talking about here. We are talking about 100% uptime. That's it. And they do that with InfluxData. They opted for the Influx Enterprise because they need also the high availability and some extra security implementation. But basically, they use the same platform to just present it to you. They also they make use of Capacitor, the real-time engine, to alert on performance deviations as well. So all the alerting that they need in terms of network monitoring, they get from Influx Enterprise and Capacitor. So if you want to see more use cases for InfluxData time series platform and Influx DB as the time series database, we have in our website. You will see Ontop, how Ontop went by selecting Influx DB as their choice for time series database. They didn't start with InfluxDB. They migrated to InfluxDB exactly for scalability and performance issues. But we have also LibreNMS, Ubiquiti, Barracuda, Secure Agent. You can see that it doesn't matter in which segment the solutions act on. What matters is it's time series, it's timestamp data. It need to be performant. You need to be scalable, and that's why they picked InfluxDB. For more resource, you can visit our solution page on network performance monitoring. We have tech papers and webinars there waiting for you. And that's what I have for our webinar today. I open to questions.
Great. Thank you so much, Daniella. We do have a few questions that have come in. The first question is, what about Elasticsearch? There's a big trend in using this engine also for time series.
Yes, I hear what they say as well, but we believe that I go back to that three main things that you cannot compromise with. You need to be real time. If you want to monitor, if you want to be preemptive, metrics first. You need to detect things when they happen. Not when you can do a query over a sea of parsed messages that you have in your system. It's after you detect, that something is not going well in terms of metrics thresholds, event thresholds that you can monitor real time. Then you can dig into contextual data in your logs. And that's the reason why we also offer Syslog data ingest via Telegraph plugin. It's one of the plugins that I made sure to make it available as part of this solution proposal for network monitoring, because it can give you contextual data about, what could be causing that deviation that you find in your metric monitoring, but metrics first.
Great. The next question that we have is, can you talk a bit about what options there are for acting on metrics? What does the stack do to enable automated alerting and actioning on metrics coming in?
Okay, so first of all, metrics is about regulating the type of granularity you want to sample on. For certain metrics in certain segments like financial, you need to be in the nanoseconds. So or in other environments like a regular networking, for an organization that is running, for example, I don't know, a website to their visitors, you may be monitoring just those typical network performance metrics in terms of, making sure that the page, response is acceptable. You don't have that delay that annoy people. And that could be caused by your network, and you need to make sure that certain things are working fine in that way. So you need to find the granularity in which you need to monitor, and that you can regulate with Influx DB and Telegraph plugins. You can define how often you want to get that data in. But once you have that data in, you can link that data straight to our engine, real-time engine. That data can be constantly queried to define, to find, points that cross the threshold that you define for alerting. So we provide, the means for you to define the right granularity of monitoring that will catch the metric that you want to catch in real time. And at the same time, we offer you the real-time analytics engine to trigger the alerts so you are aware of them.
Awesome. We do have one more question. So audience, if you do have any more questions, please post those into the questions panel. The last question that we currently have is, which programming languages have been used in the platform's development?
So InfluxData use your version of query, has your own query language, which is similar to, or actually at least is familiar to those that are used to SQL, but it's not SQL. But if you understand SQL, you can quickly start using, Influx query language. And we are working on the next version, Flux, that will be even more powerful. We'll be able to merge query with analytics. And it's also developed to be purpose-built, so it will still, be kind of understandable from a human interface. So you will be able. The learning process is very fast. You can bring all your familiarity with SQL to Influx, but it will be much more powerful.
Awesome. That does look like all the questions that we have. So Daniella, is there anything you would like to add before we close things out?
The only thing that I would like to add is, don't be scared by complexity, because you can start simple, easy, and fast. You just need to make sure that you define what you want to monitor. Once you have those aspects, sorted out on your side, we provide the entire platform for you to bring that information in, alert on, so you can act effectively.